Good afternoon. For this assignment, you will be practicing compositions. So remember, a composition is really different than any operation we've learned before. So I will do one problem on each page just to give you an idea. But the main idea is that the input of one function is the output of the other. For example, we have here, determine f of g, or f composed with g. F is 3x minus 1, and g of x is x squared. Now notice this does not mean f times g, okay? It's a very different thing. If it's an open circle like this, or if it has parentheses like this, it means the same thing. They're both compositions. So you have to take f, the input for f, has to be g, the output for g. So let's see, the output for g is x squared, and the input for f of x is x. So we're going to have to replace x here with x squared, the other function. Okay? So for this function, I usually rewrite it with parentheses because that's clearer. So I think, okay, so the input for f is g of x. Well, I say, well, g of x is x squared, so I put that into parentheses. Whatever's in that parentheses is the input. That I think, okay, I'm going to take x squared and replace the input variable with that. So f of g of x equals 3 times x squared minus 1, okay? So that's a good answer. You can also simplify it as 3x squared minus 1. Okay, and that's the composition. We put those two functions together in a new way. Again, it's not addition, it's not multiplication, it's composition. Here you have g of x, or g composed with f, g of f. You will get a different answer when you compose in different ways. Okay, here it's a number, it's the same thing, except there's a number for the very first input, right? For the function that is being composed, right? All right, that's about it. Here there's 3 functions, and notice there's a triple composition. See if you can figure out how those work, all right? Now these are all symbolic representations, but notice you can do compositions with anything. Notice we have a symbolic representation, a table, and a graph. And it's the main idea is that the input for f is the output of g. So we do have to start with g. So g of 2, we have to find out what the output is for g of 2. So let's do that. What is g of 2? Okay, well, we look at our symbolic representation. If we put, down here. If the input is 2, the output is 0. So g of 2 equals 0. Then we say, okay, that output is the input for our other function to compose them. So f of 0 equals, what is it? Here's f. What's f of 0? I go, okay, when the x is 0, the output is -6. The answer is -6. All right. So that's how we do those. Notice there's some triple. Actually, I'll do one of the triple compositions. So h of 0. Okay, h of 0, if we put 0 in here, that's 2 times 0 minus 1. So that's -1. So h of 0 is -1. So we just go from the inside, the last function, to the outside. So h of 0 is -1. Okay, then I think that's the input for g. So then we find g of -1. Right, the output for h is the input for g. G of -1 is 1. This output becomes the input for f. So f of 1 equals See, if we go over to 1, it's -4. And this is a triple composition, or I guess a double composition, because we're composing twice with 3 different functions. So you can have much more complex compositions, such as these. All right, so that's how we do compositions. It's a good way of combining different functions, or to write one function as a composition of other functions. Sometimes that's useful, or to it's just a good way to express when a value goes through several functions, I suppose is a good way to put it. All right, very good. So just work on all this. Again, the second page, the functions are represented a different way, but this page, they're all symbolic representations. So just do your best. Please ask if you have any questions. Please attend tutoring. And I will talk to you next time. All right, have a good day.